Welcome to Ask and Learn.
For fluid pressure, we have a trapezoidal gravity dam with a height of 6 meters, a bottom base of unknown dimension d, and a top base of 1 meter. Also, the water level is at 6 meters. And we are given the density of concrete and the density of water, and we are to determine the smallest dimension d to prevent the dam from overturning at point A. So first, let's divide the cross-section of the trapezoid into two parts. So we have the rectangle and the triangle, and we have the weight of the rectangle. Let's call it as weight 1, and the weight of the triangular part as weight 2. And we also have the weight of the water acting on it. So we have a downwards weight of the water, let's call as weight 3, and the water pressure. So we have a horizontal resultant of this water as F of H. And take note that we will only analyze a 1 meter strip of this gravity dam. So now we can solve weight 1. So weight 1 is equals to 1 times 6, which is the cross-section area, times 1 times 2.5 times 10 raised to the 3 times 9.81. So we have 147.15 kilonewtons. And for weight 2, we have 1/2 base times height times 1 times 2.5 times 10 raised to the 3 times 9.81. So we have 73.575 times d minus 1 in kilonewtons. And for weight 3, we have the same. So we have the area of this triangular water. So we have 1/2 base times height times the 1 meter extrusion times the gamma of water, which is 1 times 10 raised to the 3 times 9.81. So we have 29.43 times d minus 1 in kilonewtons also. And solving for the pressure at the bottom, we have gamma H. So we have 1000 times 9.81 times 6. We have 58.86 kilopascal. So now we can solve the horizontal force, which is 1/2 of 58.86 multiplied by 6 times 1. So we have the resultant as 176.58 kilonewtons. So now we can make a summation of moment at point A, which is equals to 0. So our overturning force is F of H, and the force that counters it are the weight of the water and the weight of the dam. So we have 176.58 times the centroid of this. So we have the 1/3 of 6 is equals to weight 1 multiplied by its centroid. So we have 1/2 of 1 plus weight 2, 73.575 times d minus 1 times 1 plus the 1/3 of d minus 1 plus weight 3, which is 29.43 d minus 1 times 1 plus the 2/3 of d minus 1. So simplifying this, we would get 279.585 is equals to 24.525 times d minus 1 times d plus 2 plus 9.81 d minus 1 times 2d plus 1. So further simplifying this, we have 279.585 is equals to 24.525 times d squared plus d minus 2 plus 9.81 2d squared minus d minus 1. So we have 0 is equals to 24.525 d squared plus 24.525d minus 49.05 plus 19.62d squared minus 9.81d minus 9.81 minus 279.585. So we have 0 is equals to 44.145 d squared plus 14.715 d minus 338.445. So taking the positive root, d is equals to 2.607 meters. This is the answer.